During the presentation, we will introduce the Techta system and explain what IDEXX Tecta is and how it works, including the enzymatic reactions behind the tests, and how the extraction of the indicator is a key difference with this technology. We are also going to talk about how the equipment can be used and when it is an ideal solution for continuous monitoring and where automation of sample analysis, data management, and reporting of results is needed. Finally, we will have a question and answer session where you can put your questions to our expert speakers. As stated, the title of this webinar is Rapid Automated Water Testing for Coliforms E. coli and Enterococci using IDEXX Tecta, and there are a number of considerations that our speakers will address today. I'm delighted to welcome our first speaker, Dr. Brett Brewin. Dr. Brewin is Scientific Affairs Manager for Europe, Middle East and Africa for IDEXX Water. He has been at IDEXX for 25 years and has worked in research and development, product and technical support, training and regulatory affairs. His current role involves supporting our regulatory trials, customer product validation and technical training, as well as responsibility for cryptosporidium and giardia training in the Asia Pacific region. Over to you, Brett.
Thank you, Nigel, for that introduction, and I'll extend my welcome to everybody joining us today from around the world. So I'm going to cover some of the technical details of the IDEXX Tecta unit, starting with what exactly is IDEXX Tecta. As I'm sure most of you know, IDEXX are world leaders in water microbiology, and we're very pleased today to introduce to you our latest offering, which is IDEXX Tecta. And IDEXX Tecta is a rapid automated testing system for total coliforms, including E. coli, and also the Enterococcus group. The advantages of the IDEXX Tecta is that you can test your water anytime. The analysis can be performed by anyone, as it's such a simple system, as you'll come to see, and you can test anywhere. Just to cover the system, there are two Techta instruments, the B16 and the B4, and we'll go into a little bit more detail about these instruments shortly. And there are also a number of Techta alert tests. There's a combined test for total coliforms, including E. coli. There's an individual test just for E. coli, should you require that analysis. In addition, some of you may still be interested in testing for fecal coliforms, and that test cartridge is available. And finally, there's a cartridge for the analysis of water for the presence of Enterococci. Going into a little bit more detail about the instruments themselves, there's a small unit called the Techta B4. This has a single incubation and allows for 4 tests to be analysed concurrently. It has a smaller footprint than our second offering, and it's ideal for mobile and remote testing scenarios. Our second instrument is the Techta B16, and this allows the concurrent analysis of 16 water samples. And something unique about the B16 is that there are actually 4 individual incubation mantles within the device, which allow you to run analyses at different temperatures. More about that later. There's a very, very wide dynamic range to the Techta analysis, and we can detect organisms from 1 CFU up to 10 to the 8 CFU per 100 mils. Because of this very wide dynamic range, you can analyze samples undiluted, and that's a very key advantage to the Techta device. Looking at the Techta cartridges in a little bit more detail, we have Techta Alert CCA, which allows the analysis of water for the presence of total coliforms, including E. coli. These are incubated at 35 degrees C, so we can capture this very wide and diverse group of bacteria. Secondly, there's Techta ECA, which is an individual test for the analysis of water for the presence of Escherichia coli. This test is run at a temperature of 41.5 degrees because that is the optimal temperature for the growth of E. coli, and it will allow for the most rapid results. Thirdly, there's Techta FCA, which is for the analysis of water for the presence of fecal coliforms, and this analysis is run at 44.5 degrees C, in line with current guidelines for fecal coliform testing. And then finally, we have Techta ENA, which is designed for the analysis of water for the presence of enterococci, and this is run at a temperature of 41.5 degrees C. So moving on to how does the Techta system work? We're still using exactly the same principles as we use with other IDEXX product offerings. So we're still using nutrient indicators, and we're still using the same indicator enzymes which are specific for various target bacteria. However, there are some differences. The enzyme substrates that we are currently using are quite unique. In their native format, these nutrient indicators are hydrophilic, so they like being in the water sample. However, when the target enzymes break down that nutrient indicator, it forms a sugar and then a hydrophobic fluorophore molecule. That hydrophobic fluorophore molecule does not like being in solution, and therefore it migrates into what we call a polymer partition element that's molded into the Techta cartridges. Final important fact here, we have automated detection in real time, continuous detection, and subsequently notification of positive results in real time. Just looking a little bit more at the Techta cartridges, we've tried to make these as user-friendly as possible. So we have analysis labels. You can attach barcodes to these labels. You can also attach a barcode reader to the Techta device. There is a tamper-evident closure on the device, which allows you to ensure that the integrity of that cartridge is intact and the sterility of that cartridge is intact. There's also a 100 milliliter fill line on the cartridge, and that is very, very similar to the 100 milliliter fill line for our vessels, which IDEXX also sell. The cartridges are made from polypropylene, so they're fully recyclable. And the actual reagent is contained within the cartridge, along with sodium thiosulfate, which allows chlorine within the sample to be neutralized. Finally, at the bottom, there is the polymer partition element, and that's co-molded into the bottle. And we'll go into a little bit more detail about this later. The polymer partition element is extremely important because this is what allows the accumulation of the hydrophobic fluorophore molecules, which builds up over time and signals a positive result. What are the advantages of the polymer partition? Well, some of the advantages are to do with eliminating human interpretation. So when we use our eyes to look at either a presence absence result or a quantified result, it's quite subjective, and therefore one analyst may interpret the result differently from another. With Techta, that's not possible. Everything is done with optical sensors, and therefore we take away the subjectivity of analysis. In addition, A lot of water matrices that we analyze can be very challenging. They contain a lot of color, or they can contain a significant amount of particulate. None of this affects the performance of the Techta unit. And so these challenging matrices, such as wastewater and biosolids, can be analyzed using Techta. We have continuous monitoring with Techta. It can either be run in a presence-absence format or a quantification format. With presence-absence, any signal indicates the presence of the target bacteria. And because the fluorophores have different emission spectra, we can actually detect different organisms within the same sample. So with the TectAlert CCA cartridge, we can actually detect E. coli and the total coliform group at the same time. For quantification, the signal onset, so as that hydrophobic fluorophore molecule builds up within the polymer partition element, it reaches a threshold, and that signals a positive result by the Techta device. It provides us with a time to detection of a particular target organism, and that time to detection is linearly related to the log of the bacterial concentration. That is the basic principle of bacterial growth kinetics. Time to detection can be correlated with the concentration of bacteria. The time to detection is extremely important because, again, this will signal the bacterial concentration. If the time to detection were 2 hours, you would have a very high concentration of bacteria. If the time to detection was much later, perhaps 10 or 14 hours, we would have a lower concentration of bacteria. So this principle of bacterial growth kinetics is very key to the Techta technology. Some advantages of continuous monitoring. We can get results for the presence of the total coliform group, including E. coli. Could be very rapidly in 2 hours if the concentration is significantly high, which we might expect with, for example, wastewater analysis. The time to detection could be much later. And also for negative results, the incubation time is going to be 18 hours. We have this extremely wide quantification range from 1 CFU to up to 10 to the 8 CFU per 100 milliliters. And again, that means we do not have to dilute the sample to perform the analysis. That is extremely significant because when we start to introduce dilutions, we start to introduce bias and error into the results. That would be particularly important if we were testing wastewater, where we have significantly high concentrations of bacteria. There's a lot of data management with regards to Techta. It's 100% objective, automated, and very secure. This can be networked to your IT network within your laboratories. Reports can also be downloaded to USB sticks. Emails can be sent directly to your personal mobile devices, which will allow you to respond to positive results immediately. Also, all of the data is available as a CSV file, so it can be integrated with your LIMS system within your laboratory. Wherever you are, wherever you're testing, the results can be sent live to these systems. So how do we use the IDEXX Tecta? Simple, it's fast. You simply break the tamper-proof seal and open up your device, add your water sample up to the 100 milliliter mark, exactly the same as you would for all other IDEXX tests. You then allow the reagent to dissolve just by simply swirling and waiting for a short amount of time, and then reseal the lid of the Techta Alert cartridge. You then go to the Techta instrument. There's a very simple user interface where you can input your sample ID, choose the type of test that you're performing, whether that's total coliform E. coli or E. coli only, or enterococci or fecal coliform. You choose your sample size, which would typically be 100 milliliters, and then place your device within the Techta instrument, close the lid, and it will automatically detect that cartridge and begin incubation and real-time analysis of the sample. It's the easiest and fastest method currently available to conduct a test. Again, anyone can run these tests. They can be run anywhere and at any time. Again, coming back to the user interface when the analyses are running, very, very simple to interpret test results. If the chamber indicator is amber, that means the analysis is ongoing and the Techta is continuously analyzing that sample. If the chamber indicator is green, that indicates that the test is completed and no coliforms, E. coli or enterococci, so no target organisms have been detected. If the chamber indicator is red, that means the test is complete and target organisms have been detected. At that point, whether that's 2 hours, 6 hours, 18 hours, an email will immediately be sent to registered email addresses, allowing your analyst to respond in real time to events of contamination. Every sample analyzed gets a very simple report to interpret. It gives you a chain of evidence of the sample ID and details, the incubation temperature that was used, automated temperature recording, the type of test that you selected to run. It will give you a presence-absence format, and then a time to detection and the correlated concentration of bacteria. And again, all of these available as CSV attachments. I'll hand back to Nigel.
Thank you, Brett. So please, if you have any questions for Brett or for our subsequent speaker, please remember to put them in the questions tab, and we will endeavour to answer them at the end of the presentation. Now, our next presenter is Andrew Headland. Andrew Headland is a Bachelor of Science and a Master of Business Administration. He is Associate Director for IDEXX Water EMEA and is also in his 25th year with the company. Previous roles have included responsibility for EMEA sales and setting up our water operations in Africa. Andrew is currently the General Manager of our Newmarket facility, where we manufacture the Cryptosporidium and Giardia testing product line, and also has responsibility for our EMEA marketing and scientific affairs teams. Over to you, Andy. I think you might be on mute.
Apologies, I was on mute. Sorry about that. Thanks, Nigel. Thanks also to Brett, and good day, everyone. Now that Brett has explained the technical principles of the Techta system and also its operating procedure, I'd like to close this presentation by discussing just how laboratories can use the Techta system. So in this section, I'm going to focus less on what the instrument does and more on how it helps laboratories and water utilities operate in a new and different way, solving workflow problems and ultimately delivering better public health. So the solutions that I'm going to cover in this last section are rooted in the three primary benefits of IDEXX Tecta. As you heard from Brett, that is anytime, anyone, and anywhere. So from a practical perspective, anytime. Because the read window is dynamic, you can start a test anytime, day or night, without worrying about staffing the lab during the end of the read window. Secondly, anyone. So as you've already seen, the simplicity and ease of use of the system means that nearly anyone can operate the instrument with only some very basic training. And finally, anywhere. The lab in a box functionality means that Techta does not need to be located within the four walls of a traditional laboratory. As long as there is access to mains power, you can run the instrument. So here are some specific examples in order to illustrate the anytime, anyone, anywhere mantra. And just before I start, I noticed that many of you have been active in our chat box, sending us your greetings. So thank you for that. And I'd like to continue that interaction by asking you a question. We'd like to know in your laboratories what types of emergency, or maybe you call them rush samples, that you handle. We'd be very interested to hear your feedback on that. So if you could put that in the chat, we'd be very grateful. So this then is the first example that we're going to give. It's construction or emergency testing, where the Techta system is highly suitable. So we all know that emergencies don't happen on a convenient schedule, and also that construction or operations teams don't always work to the lab's timelines either. So when you are dealing with one of these situations, the fact that you don't need staff to be in the lab at the end of the read window means you can start the test at any time. Tests, therefore, can be started pretty much as soon as the samples come in. So let's say that a construction sample comes into the laboratory at 1 p.m. in the afternoon, and that you're using cholera 18. You're probably not going to start the test until 3 p.m. And that's because you won't have someone to read it until 9 a.m. the next morning. But with Techta, you start that sample right away. And let's also imagine that specific sample is coliform positive. With Techta, you could get that result quite early via email, say 9 p.m. or 10 p.m. the same day. You can then let the distribution manager know straight away so that their teams can be responding and resampling as soon as they start work the next morning. There are many other examples such as retests and boil notices and so on. And in all of these cases, the ability to start a test anytime and get an early positive result means that you are cutting hours and sometimes days out of these emergency situations. So just looking at your chat responses, quite a lot, thank you. Some people are already using the system, which is great. Rush samples will be consumer complaints or commissioning of pipelines. Thanks, Monique. Freshwater lines breakdown. Use the test to see how much we need to flush before re-establishing the line. God, they're coming in thick and fast. Thank you. Emergency samples, drinking water for compliance. Scrolling back. You think about anything else to get a false positive? Brilliant. Thank you very much. I mean, I won't read all of these out, but we really appreciate your responses. Commissioning a new reservoir. Excellent. So I guess the point that we're making and the point that I think you're reinforcing is there are many scenarios where the Techta actually will bring value to the laboratory and to your operations. So I have another question, a bit more of a simple one. Many of you work in a lab that is staffed for 5 days a week, or maybe 6, rather than being staffed all year round every day. If you could let us know in the chat box again, we'd be most grateful. Because the next benefit of Techta relates to this question. If your laboratory needs to test the day before a weekend or a public holiday, you now can, without requiring staff to actually come in physically the next day to read the results. Again, it's all about the read window. You don't need to be there when the test ends. You only need to be there to start it. Pretty much any other method, you need to be there at both the beginning and the end. So again, this can make a real difference as per the previous slide, especially in situations where there's an emergency or retest sample. A lab can now accept those samples where previously it may not have been able to. So going back to our chat, Monday to Saturday, no staff on Sundays or bank holidays. Thank you, Neil. Mariana, we work 5 days a week. That's a question. Ahmed, if you've got questions, can you put them in the questions tab, and we'll endeavour to get back to that towards the end of the presentation. Clarissa, 5 days a week. Monique, yes, you work for a very big lab, 7 days a week. We understand that, 365 days a year. But it seems that most of the responses are either Monday to, 5 days or 6 days, and not Sundays or bank holidays. So again, you can see the advantages that Techta brings to these situations. So we have one final question for our interactive section. Again, primarily for those of you who actually work in a physical laboratory. And we'd like to know, what is the furthest distance a sample has to travel to get to you, whether that's in miles or kilometers, or if it's a shorter distance but it's a major city, maybe what's the longest drive time that it takes to get a sample to your lab. So as I'm sure you are all aware, water treatment plants are very often far away from the main population, especially for surface water. That is, as you know, one of the key features of water supply planning, and that's making sure your source water remains as free as possible from contamination, which typically means putting them as far away from people as is possible. So here's a novel idea that utilities can use, and that is setting up a Techta remotely and connecting it back to the lab virtually. This way, when there is a one-off sample collected in the middle of a large city, for example, the operator can take it to the Techta that's located close by, instead of taking a lengthy round trip to the lab. For example, in the US, we have a large utility lab already doing this, and they believe it saves them at least 90 minutes of driving time for each of these individual samples. So obviously this could save time and money and emissions over the long term. Plus it makes the field crews far more efficient because they're spending less time in the car and more time in the field. So once again, going to, nice one, 1,000 kilometers, that's a long way. 1 to 6 hours, that's a long time. Thank you. Lorraine, we need to get water samples in within 24 hours. However, wow, we have to have samples brought in by helicopter and boat. Wowzers. Other people need to be in within 8 hours of sampling. Drive for 8 hours. Drive time is between 4 and 5 hours. Thanks again, Monique. Excellent. Brilliant feedback. 220 kilometers. Lots of long distances. Thank you. So again, sort of reinforcing what we're trying to say here in the message, that by taking a Techta machine closer to the sample, you can save and improve in many, many ways. So thank you again for your interaction there. That's the last one in the chat box. So that's the last question we have. So now let's talk about beaches and recreational areas, swimming areas. Again, similar to the previous slide, these are often located far away from a testing lab. And again, this means long drive times, but more importantly, it could also mean that test results aren't available until later the next day at the very earliest, which could subsequently mean the beach is kept closed unnecessarily, or even maybe it's being kept open when it should have been closed. So again, by having a unit located near a major recreational area, like a beach or a lake, a trained staff member could collect the sample and begin testing pretty much immediately, especially after weather events like heavy rain. And with the rapid notification that you get with Techta on highly contaminated samples, you can reduce the time to result, so you know pretty much right away when closure is required. Another thing to mention is the possibility of locating a Techta instrument at the treatment plant for operational testing. Operators can easily be trained to use Techta, as you've seen from Brett's presentation. The tests can be used to verify the effectiveness of your treatment process, and it can give results in either a presence-absence or a quantitative mode. Some labs already use Techta for this type of non-compliance testing, and they use the test to make treatment decisions or to verify that the treatment process is actually achieving the required reduction in bacteria concentration at various points in the process. Complex matrices, such as processed waters, recycled water for reuse, wastewater, and biosolids, they all have a significant particulate load and often can be highly coloured. This then can cause problems with most microbiological methods, and dilutions are nearly always required. Techta has a distinct advantage here, as due to the design and the technology, particulate load and colour are not an issue, and dilution is not required. And finally, thinking about locations that are generally inaccessible to laboratories, examples include maybe a cruise ship, military bases, remote communities, and other industrial sites. These are typically settings where samples are shipped very long distances and at great expense in order to test the water quality. Techta can solve that by bringing the lab in the form of the instrument to the remote area. You don't need to build a standalone lab, you just need a mains power source. A great example here are Canada's Indigenous communities, the First Nations. Techta is used in many of these locations, allowing communities to test the water on site without shipping samples to a faraway lab. Results come in faster and ensure better public health outcomes for these communities. So, to summarise and conclude our presentation today, we have seen that IDEXX Tecta is a novel, fully automated, rapid, on-site testing system. Detection is based on an enzyme substrate reaction with quantification based on the principle of growth kinetics. The advanced polymer partition technology overcomes colorimetric and/or turbidity interference. And the automated read eliminates any chance of human error or misinterpretation. Having results received by email in real time enhances operational responsiveness, as well as improving data management. And the technology is complementary to other IDEXX offerings, providing multiple solutions for multiple situations. We like to call it a lab in a box, which will improve operational control and effectiveness in a very wide range of applications. Hence, anytime, anyone, and anywhere. So with that, I would like to thank you all very much indeed for your interest and for your time, and especially for your contributions and interaction in the chat box. And I'll now hand back to Nigel for any questions that you may have. Thank you.
Thank you, Andy. Well, that concludes the presentations from our speakers. Excellent insights, everyone, and thank you. We do have quite a few questions coming in. So what I'd like to do now is we'll start the Q&A session, and we'll go through some of those questions. So the first question that I have, and this is one for you, Brett, could you tell us, please, a little bit about the accuracy of the method, i.e. the false positive and the false negative rate? I think we saw that in the questions coming through.
Yeah, thanks, Nigel. So yeah, the Techta methods generally have very low false positive, false negative rates, so high accuracy compared to other traditional methods and other IDEXX methods. If anybody really does want specifics, we can happily share some of the studies that have been performed. But as you know, all IDEXX methods have been characterized according to the standard ISO 13843, where we generate categorical characteristics for sensitivity, specificity, false positives and negatives. And again, there have been some studies using the Techta where we've also been able to quantify false positives and false negatives. So happy to share those with you after the webinar ends.
Thank you, Brett. Another one for you. Is the ECTC media the same as the IDEXX CoLalert media, please?
No, it's not. It's a different formulation. However, it is based on exactly the same principles as the CoLalert 18 tests. So it's nutrient indicators and it's enzyme substrate technology.
Okay, question for you, please, Andy. Will these units be battery operated?
Yeah, I was expecting that one. Thanks, Nigel. Short answer is no. The power requirement to incubate samples for 18 hours is just too high to use a battery for like the entire incubation. We usually recommend a normal UPS battery backup in case labs get short power outages. But in terms of battery complete supply, you need mains power.
Thank you. And Brett, one for you now. How long does it take to read a sample for presence absence on the instrument?
It's really going to be dependent upon the concentration of the target bacteria, whether that's coliform, E. coli, enterococci. If the concentration of bacteria is high, you could have a result in as little as 2 hours. If the concentration is much lower, that you, for example, as you would expect in potable waters, detection may not, or a positive result may not appear until very close to 18 hours. Also, it's useful to know that the full incubation read, so the full 18 hours, is required to confirm a negative result.
Thank you. One for you, Andy. Can you have multiple emails on the results email?
Yes, you can. You can list as many emails as you choose. I know that a lot of our customers also use shared mailboxes as well. So yes.
Thank you. And Brett, what is the endpoint of the reaction if the result is positive? So in other words, if you imagine that the instrument reads or sends a positive sample at the 10-hour point, what if the final result goes higher in 18 hours?
So the Techta system uses algorithms and calibrations based on the earliest time that it detects the presence of target bacteria. And once the target bacteria is detected, the test is stopped. So if the time to detection is 10 hours, that positive result is immediately sent to the end analyst. Again, this is all based upon bacterial growth kinetics, where that time to detection, the initial time to a positive result, is then correlated to the bacterial concentration. So the result will not increase past the first positive result.
So another one for you, Brett, an interesting one here. Can you add or remove cartridges while the unit is still running?
Yes, you absolutely can do that. So as long as the test is completed, you can remove that cartridge, read the report, and you could start the analysis of a subsequent sample. Similarly, if you've started a number of samples and more come into the laboratory, as long as there are chambers available within the device, you can start those tests running. The Techta unit individually controls the analysis, temperature and time of each individual chamber.
Thank you. And Brett, what is the sensitivity at the detection limit?
So again, as we've already said, there's a very wide dynamic range for the performance of Techta. So the limit of the detection would be 1 CFU per 100 mils. However, we can analyze without dilution samples with much higher concentrations of target bacteria, up to 1 × 10⁸.
Thank you. So we have a couple of questions regarding enumeration. So the first is, can Techta be used for enumeration in drinking water for both E. coli and enterococci?
Is that for me, Nigel?
Yes, sorry, Brett, yes.
Okay. Can Techta be used for enumeration in bathing water? Sorry, could you just repeat the question?
Yes, sorry. We have a number of questions regarding enumeration. The first question is, can Techta be used for enumeration in drinking water for both E. coli and enterococci?
Yes, so drinking water tests give either a presence-absent result or a quantified result. But one thing you should know is the method is not currently approved for compliance testing in Europe. So, please contact us to learn more. And as Andy indicated during his presentation, there are unique situations where you're using non-compliance testing to speed up your reactivity to events.
Another one for you, Brett. This time, enumeration in bathing water, fresh and marine, for both E. coli and enterococci?
Yes, again, the one caveat there is that marine water samples should be diluted 1 in 10. And that's not because the dynamic range capability is not there. It's because of the salinity in the marine water, which can affect performance of the test itself. And again, just to reiterate, it's not currently approved for compliance analysis, but rather non-compliance in situations where you might need a rapid response.
Thank you. A couple for you now, Andy. Can you fill the actual test bottle out in the field?
Yes, you can. I suppose the only caveat to that is you should always pour the sample into the collection vessel or the cartridge. If you dip it into the water source, say you're doing like a surface water or recreational water, the reagent will flow out. So yes, but with care.
Thank you. Another question for you, Andy. If there are temperature confirmations required when samples are incubating, how would you verify the incubation temperatures?
Okay. Yeah, we do have a protocol for verifying temperatures, and that's utilizing blank samples. So yes, it's possible, and has a set procedure. And also there are holes on the side of the instrument where temperature probes can also be inserted.
Thank you. Back to you, Brett, please. Why do marine samples need to be diluted?
Okay. Yeah, I'll just refer back to my previous answer regarding analysis of recreational waters. The salinity in marine waters is a factor that can affect performance of the Techta cartridges, and therefore it needs to be diluted at least 1 to 10 to reduce that level of salinity to suitable levels where it's not affecting the performance.
So Brett, again, another one for you, please. We have samples shipped from across the country. Samples are collected and shipped overnight to the lab. Would this structure fit with Techta?
So yes, this would fit with the Techta workflow. The caveat to that is that the samples cannot be collected in the Techta cartridges. So if you collect samples in a different collection vessel and then ship them to your lab, that absolutely fits 100% with the Techta workflow. However, if samples are collected in the Techta cartridges, sample analysis should be initiated ideally within 1 hour. So then shipment would not be possible.
So a couple more questions before we wrap up. So again for you, Brett, once a water sample has been added to a cartridge, when does the sample need to be inserted into the instrument?
Again, coming back to my previous answer, we recommend that once the sample is added to the cartridge and it's mixed, it's placed within the Techta instrument, and analysis is initiated within 1 hour.
Okay, and just wrapping up now, Andy, there are a couple now for you. Another interesting one just came in. But what type of maintenance is required for the B16 and the B4 instruments, please?
Okay, thank you. Yeah, sort of two sort of sections to this. So you would require to do periodic chamber verification, and we do supply a validation cartridge to do this. In terms of frequency, that absolutely depends on the level of use of the instrument. Again, if you've got an idea of usage, then our technical support department will work with you to help you understand the frequency. And also, as with, I guess, with most instruments, we would always recommend cleaning, especially the optical windows, after use to maintain a sort of optimal performance. And the instrument comes with an instruction manual, which has all these details in it.
And finally, Andy, can you tell us, please, the shelf life of the Techta cartridges?
Sure. Yeah, I saw that question come in. They have a shelf life. All of the cartridges have a shelf life of 15 months from the date of manufacture. And just to say that the recommended storage conditions are between 5 and 30 degrees Celsius, and conditions of less than 60% humidity.
Okay, thank you. So thank you everyone for your questions. I think now may be a good time to start to wrap up. If we were unable to get to your questions, we will be following up with you directly after this webinar. But we're almost out of time for today, and thank you so much, Brett and Andy, for your presentations. I would also like to thank Nancy, Clint and Stephen for keeping things running smoothly behind the scenes. And of course, thank you all for taking the time to join us today. For more information, please visit idexx.co.uk/water/education to see information about upcoming webinars, and new and featured courses on the IDEXX Water Academy, and to read the IDEXX Currents articles. At the IDEXX Water Academy, you can also find a course called IDEXX Tecta, Automation in Water Microbiology. This course has lots of useful information about the system and how it works. To learn more about Techta itself, you can visit our website at idexx.co.uk/Techta, where you can find additional information about the Techta and water microbiology automation. So after the session, you'll receive an email with a link to today's recording. The recording will also be available at the IDEXX Water Academy in the next day or so. So if you have a question after the session, or you're watching the on-demand version of this webinar, please feel free to contact us at EMEA-TechSupport@idexx.com, and one of our technical service people will follow up with you. Please allow some time for us to respond to your questions. So thank you again, everyone, for your time and participation in today's session, and we look forward to seeing you again at an IDEXX webinar in the future. That concludes today's webinar. Thank you.
Thank you.
Thanks, everyone.